Hey, Hiram. Are you the only one in class? Well, it hasn't started yet. Well, it has just a minute ago. Well,
Well, so far, looks like I am.
yeah, so you can
I
have a one-on-one class.
I guess so. In that
Yeah,
case, I have a bit of a question.
yeah,
I
sure.
was doing quest 4, and in one of the ones that returns a string from a double, um,
Uh-huh.
my output had one extra trailing zero on the
Yeah,
end of the
so you got
decimal.
to you got to figure it out. It's
Okay.
very easy. You'll find out. Okay,
Okay.
you can use Google. There's only a few different ways in which you can convert a float into a string in C++. Any language, really, right?
Okay.
If you're given a number and someone tells you, oh, here's a number, give me the string version of that number, right? There's only a few ways you can do it, really,
Okay.
programmatically, right? You can, for example, in Java, you'll say integer.stringify or something like that, and give it an integer, it'll give you a string form, right? Maybe in some other language, you might say, oh, here's a floating point number. Give me a string version of it with 5 decimal places max.
Mm,
Yeah. So there is a way. There is a way in C++ where you can specify this to excruciating detail.
okay.
All right. So
Okay.
it's going to be fun to find out, right? Because if I tell you this is how it's done, mainly because you know there's so many different ways of doing the same thing. I think that's what it is, right? So in C++, in programming, well, in teaching in general, in teaching itself, I think people should never teach a particular way of doing this, and the reason for that is because unless you are beholden to the mistaken notion that there's only one way to do things, there's only one truth, this is the only way you can find it. If you go any other way, you are, you know you're doomed, right? So if people believe silly things like that, yeah, well, it's up to them, right? They have to be like super lucky that they do find what they're looking for in the one path that they're looking for. So therefore, I think that if we're learning computer science, taking this as an example, there's so many different ways to do it. If I tell you this is the way you do it, that is basically taking your lunch and eating it, because there are so many different ways, some interesting ways of doing this that you'll never find out, right? If I didn't tell you, you'll just go Google and say experiment and say, hey, now I know 10 different ways of doing it, although the quest only asks for one way of doing it, right? So that's the reason I shy away from these things, actually telling people what to do in these quests. And then many of the things in the quests are open-ended, and deliberately, instructors and the tutors in the STEM Center all been instructed not to tell you, because that basically takes away. That's what you paid your fees for. How many ever, hundreds of dollars it is. That's what it is. It's not, and you pay your money and you come here and also have the teachers and instructors eat your lunch. That's useless. So don't, yeah, that's the reason. I think, what, ultimately what happens, I think this is what all teachers um, hope their students, because we're not, a good teacher, I think, never wants to teach facts, right? Anyway, this is I don't know, maybe it's in the ancient Gurukul tradition or something like that, right? So what they want to do is basically to teach you to look for and train your way of thinking in a particular way. So I don't, as a programming instructor or computer science instructor, I don't want to teach you this is the way to do this in this particular programming language. However, your thinking about the problem should basically just be, you're thinking about it in a different way because you're used to living life in a different way. You're thinking about it in a different way. So the whole idea of this part of the education would be to say, hey, there's another way to think about this too. Think about this, look like this. And and so nudge you to say, open up your mind a bit more so you can see multiple ways of, arriving at the solution. This is one way. And there are bound to be lots and lots of cool things that you can discover in this land. So, and actually that's why, if you take Facebook or YouTube, people always say there's a lot of trash on these things, right? But it's just like life, right? I mean, people could look around in their life and say there's a lot of trash here, there's a lot of trash. And obviously, yes, of course, but that's because they're looking at all the wrong places. They're looking at the trash. Well, who asked them to look at the damn trash? Because, you know, there's a lot of good stuff too. And so they got to look at the good stuff, and they say, wow, there's a lot of good stuff everywhere I look. There's just good stuff, right? So and so like that on YouTube and Facebook, a lot of people, you know, are unable to discover these gems, right? So but you know, I think that I mentioned this a few days ago. There is a channel on Facebook called Veritasium. I think Maddie or someone, not Madison, Maddie, yeah. She posted a link. Also, there's another one like that. I think the Action Labs. This guy used to be an engineer at NASA here, I think, right? And he posts some really cool, but you know, the thing to be interested in these videos, I think, when you start watching these videos, is not the particular thing that they're talking about, right? Although they make it all interesting, right? So these guys, they've, you know, they have the way of thinking about these things, and also obviously successful YouTubers and so on, right? So they know how to distill the things that are going to be appealing as well as informative. So, but you got to look past the appeal. And say, well, I'm not interested in this particular gravitational pulse problem, but I'm interested in how he's thinking about it, right? So assuming it's not a gravitational pulse problem, maybe it's you know, something else in math, right? So if you look at all of these different examples, then we can try to look at, you know, what is it, how is it that this guy is thinking, right? He's got nothing, the Action Lab guy, right? So sometimes he has nothing at home except like a plastic cup, right? And water from the tap. And a comb or something, you know, had comb he runs through his hair, right? And he does some interesting experiments right there, and he comes up with an explanation, right? And it's interesting, and it's kids get drawn into it because there's this funny thing happening to the, you know, a stream of water and so on. But you know, as what we need to do is just detach from the kid face to say, okay, let me look past the entertainment part of it and see how he's thinking, right? What is it? Why is he interested in this, right? What is it that makes it curious for him? Right, and then you say, "Wow, that makes it curious for me too," and I think that is a dream of the goal of every teacher, is not to just load you up with facts, because what's the use? You can get these facts anywhere you want, right? You know, there's Google and Bing and all these guys out there that can do a, you know, trillion times better job at me than me at giving you these facts, right? So I think the goal of teachers is to just use these facts, selected facts. Because we have a lot of these facts out there. What I want to do is, based on the patterns of interaction that I have with a particular bunch of students, right? This quarter, you guys, we have a different kind of relationship, right? So maybe next quarter, a different bunch of students, different kind of relationship, right? So the same facts may not help me to elucidate or use them as examples to bring out certain salient points about computer science, right? So each quarter, so that's how I figured out I could live with this thing and make it interesting continuously, right? Because otherwise, if I'm just going to teach you the same damn material every quarter, I'm going to get tired of this, right? Very soon. And maybe take early retirement or something like that, right? But but this way, I thought this would actually be cool, because, you know, really, I'm not trying to teach you individual facts about computer science. What I want to teach is just a computational way of thinking about it, because a lot of people as humans, especially the ones who are I think, you know, psychologically or pseudo-psychologically, the people who are more reluctant to defer their gratification, saying, well, you know what, good things are going to happen, but it's going to happen after 15 steps, not going to happen after one step. Right? So if you're happy with that kind of solution, you have 100% certainty of arriving at the solution after doing a lot of things, right? And you say, okay, now I know I can get there, but until then, I just have to be in this brain-dead iterative loop, right? A lot of people aren't willing to do that. And so they can't get to that solution. But that is actually a valid way of thinking about problems, right? And children especially, right? If you take very young children, they don't have the computational way of thinking about things, right? Everything has to be spontaneous and immediate. Bam, 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 right? See, I'm pretty sure you're seeing little babies, right? So not babies, but kids, right? So everything is immediate. But I think as you get older, you're able to simulate more and more of the world in your head. And then you're able to see, right? Well, you know what? In 15 steps, that's where I'm going to be at if I go down this path, right? But if I zoom in very closely, these 15 steps don't make any sense, because they don't give you individual progress one step at a time. Maybe they do, right? A contrived way, but in your mind, you keep that 15th step fixed as the vision, because that's your guiding light too, right? Because that's, no matter where you sidestep, you can always course correct, because you can go towards the light. So you take that distant vision and say, I'm going to defer my gratification until then, and to get there, I'm going to go here. And obviously you have a probability distribution and all, right? So you want to know, it's not 100% if I go down this way. So your brain will work out, through experience, the right distributions and figure out, this is the way I should take. But many times you actually have 100% path too, right? And people don't take the 100% path because it does involve some difficulties along the way. And I think C++, and thank you, Hiram, you asked a very innocent question about how to format a float into a string, and I launched into this whole tirade about, but I think that is, I think that is the truth, right? Because any teacher, maybe they haven't thought about it. If you ask them, this is what they want, right? They don't want to load you up with facts. They just want you to be able to look at the facts and come up with, so I might choose, facts ABC because that's the best for this, group of students. And we have a lot of interaction going, right? XYZ for someone else. But that way, different things, right? And we also get an option, right? All the YouTube videos will be different, right? Otherwise, the same video, right? I mean, so for next quarter, I'll say, these 15 videos from the 15 previous quarters, watch any of those, right? The students are totally lost. Right. So and this way, I can say this is the topic, and there's a whole bunch of videos, different concepts, right? Different examples talking about the same thing. And that would be really useful for future students, I think, right? Because for every concept, they pick and choose between, I want it explained in this way, right? I want it explained using that particular algorithm. That kind of cool. I think that will also give me an opportunity to create lectures for my 2B and 2C classes, right? Because 2B and 2C, it's harder to do a 2-hour lecture because, the problems are bigger. And I think what we need to do is just pick out simple, not simple, pick out chunks of, places where people get stuck and talk about those. I don't know, we'll have to figure out, hopefully with students' help, we can tease out certain. But at the moment, my 2B and 2C are all online, right? So everything is online. But hopefully you guys will, many of you guys, I hope, are some of you at least planning to go on to 2B and 2C with me? Yeah, yes or no? All right, well, you don't have to make up your mind. You don't have to make up your mind. But if you do, they're online. But if you do, just feel free to ask for a lecture anytime, all right? So just get five of you together. And say, this 2B or 2C concept is really confusing, right? I want to know, can we have a class on why, if you, in a hash table, if you just increase your probing location by the square each time instead of linearly, you are guaranteed never to get stuck in a loop. It's a very interesting problem, isn't it? Because there's something called a hash table, dictionaries in Python, right? So you use, and how you locate keys and empty places in here. There's many ways in which you can find an empty home, right? But if you're searching through an array, right, for an empty home, we can do this today, right? Oh no, I have a promise we'll do refactoring, right? We'll do refactoring and then we'll also do this problem, right? This is an interesting problem, right? If you have an array and there's guaranteed to be an empty spot in that array, all right? How would you find it? How would you? Oh, no. There's no guarantee that there is no empty spot in the array, right? And you don't know. Oh, I think we have to frame the problem, right? So I'm thinking of, if you keep going in a circle and you don't know where you started, you could just end up in an infinite loop. But we can come up with a problem that embodies that conclusion. But that's an interesting problem, right? It's searching an array for an item, and with the risk of basically looping forever. So there's interesting ways of getting around it. And as you get to 2B and 2C, you'll see, right? You'll actually get to implement firsthand, right? And experience this and say, wow, you know what? If I didn't do this, I mean, I would have, if I didn't do that particular thing, I could have got stuck in a loop. And my program, used by 1 billion users out there, they all could be frozen, bam, like that, right? So, and those are things we learn to avoid, right? Because, think about it. Right now it's cool, right? You can write a program, fun thing, and you can release it, even release it on the web. It's all okay, you're safe, right? Even if it breaks, nobody's going to care. But, maybe in 10 years, you're going to be, you would have started a company or something like that. You got a product that people are paying money for, or even if they're not paying money, they've committed some part of their life and time and effort to using it, right? Which is actually saying a great deal about your product, right? And imagine if that, your product blows up in their hands. Not blows up mean exploding, right? So it creates a really bad experience, and it makes them regret that they installed it in the first place. Yeah, and they'll never ever install you a product from you again, right? And so I think that because there are so many products out there, there's so many out there, so you got to really be at the top of the game. And also, even if you're at the top of the game, right, you got to constantly be looking at the quality of the product, right? Because, when you're at the top of the game, sometimes people get complacent. I really shoddy product saying, well, I've already got momentum due to my brand, right? That'll carry it forward. And, and that attitude should not creep in, right? So the engineers always have to be young, and they shouldn't care about the brand. They should only care about the problem being solved. And then that way the company can also continue to make major progress. Because once a company gets past $100, 100 people, not $100, right? 100 people, it actually gets really, really hard to get solid engineers. It's possible, but you got to settle. And once it's 10,000 or 50,000 people, this is really hard. There's going to be a lot of people who are just doing day jobs, come there for for getting money and so on and so forth, and who are also happy. They do a decent job, but they're also happy to perform exactly the work that's given to them, which means that someone has to do thinking for them, right? Well, what they're saying is that and it's a perfectly great way to live your life too, right? So you can basically join a company and say, well, I'm going to give you my limited intellectual cycles, which can basically code up some algorithms and so on, but you got to do your own thinking, right? I'm not going to give you my thinking part of the head is trying to solve your problem, right? You solve the problem, you figure out what to do, and tell me what to do, and I'll do it for you, right? And that's a great way. That's basically a contractor on payroll, something like that, right? And that's the way people want to do. And there are lots of people that do that too, right? And especially if you've got a big company, you got to have a lot of these people, right? Who are basically faithful, trustworthy deliverers of sub products on your payroll, right? Well, you don't care if they're idle other times, but when there's a crunch and something needs to get done, you just call them in, like the SWAT team, right? And say, all right, yeah, hey guys, go ahead, let's get this done, right? And they'll get it done. But they're not going to do your thinking for you and saying, hey, what am I going to do about this, drop in a click-through rate or some shit like that, right? So they're not going to think about that. And they recognize that you're not paying them for it too, right? So that's a great relationship to have. But if you have a product that's out there, you need to, and you're thinking for the product and you're doing the thinking, you got to think in the shoes of the user. And you got to say, what if this blows up in my hands, right? And there's so many products out there. They'll just install a competitor, and they'll say, anytime you release another product in the future, they will say, what if this deletes my phone, right? They're not going to. So that's the idea, I think. Anyway, what time is it? 8:15. Oh my, 8:18. All right. Okay. I don't know how we start. Well, what do we want to do today? Do you want to? This week is, as I said, arrays related problems, anything to do with arrays, native arrays, right? Once you get to know, right. These two classes, I prefer that we know about native arrays, right? Native arrays meaning the arrays. I don't know. I didn't even look. I'm sorry. I didn't look at the code that you guys wrote, but I think I heard, a lot of it, but I didn't. Did you use native arrays or vectors?
I think native arrays.
Native, that's great. That's great. Yeah, that's great. Thank you, Alex. All right. So because vectors are so easy, and later on from next week we'll just use vectors. But before we use vectors, I want us to use native arrays, right? Because just to understand what arrays are and what vectors have inside of them, right? Vectors are basically arrays for all practical purposes, because they take this native array. It's a complex native array, right? The kind that you have, not complex, it's a simple contiguous bunch of memory locations, right? That's your native array. It's inside the vector, it's in there. But it's because it's so hard to understand for many people, vector, the class vector, which you guys will start implementing in just a couple of weeks, right? So there's a wrapper called a vector class on top of your native array that says, okay, all right, I got a native array on this side, but you can call me a vector. And if you want to do things with this array, you tell me what to do, and I'll do it for you on this array. So you only need to know some generic, simple vector functions that are safe too, right? And there's a lot of unsafe operations with with arrays, right? Not all of them, but some unsafe operations, right? Because if your array is only 5 bytes long, and you try to access a 6th element, that's unsafe, right? Well, that's unsafe even a vector. There's other unsafe operations that a vector will basically shield you from performing, right? But this is an example of an unsafe operation, which
I have a question. So there's like an array.h and then a vector.
Yeah. Oh, is there an array.h? Where is an array.h?
There is. We did an include array one time.
I don't think so. I don't believe there is an array.h in C++. I haven't used one. Okay, let me put it that way. Okay, and also vectors. Why would people have an array unless it's something like an array list, which is basically a linked list masquerading? No, I don't think so.
I don't know. I'll Google it. Thanks.
Yeah, no, we can Google it now. Someone can Google it. I don't think there's an array.h unless it's a custom array.h for some company, right? I think there's vector, which is basically pretty much a solid array in
There's an array header apparently, but I
where
don't
is
know.
it? Can someone show it to me? Can someone show it to me? I'm curious because I have never used it, and I don't know if there's a use for it. Unless they, what is the promise? What do they give you that vector doesn't, or you can't get with native arrays? Array. Oh, include array C++ reference. Which year is this? But I want to see what's in it, right? Yeah, standard array reference. Just click on that.
That's it.
Why would they have a class? I got to look into this, but let's forget that this exists.
Okay.
Yeah, let's forget about this for now. A template. You can have an array of anything anyway. Why? Oh, is this just a fancy way of declaring what you guys might have done? And maybe this is just a fancy way of declaring. Oh, there you go. It actually does have some methods. Oh, it has. Oh, I see. Okay. All right. So you see element access. You see this element access? So what they're doing is basically giving you a very, very simplified version of vector called an array, which only gives you those actions. You can square bracket index into it. You can have dot add fifth element, dot add, that kind of thing. And say dot, give me the first element, dot front, give me the last element, dot back. And I don't know what, dot data is basically just give me the native array, pointer to the first element, bam, like that, right? So they're just giving these functions, methods, right? Functionality. I don't know why they're doing this, because all of this, every single one of these is also available with vector, and really vector is not a heavy duty class. And unless they put a whole lot of shit into vector now, but even then, right, it's just compile time, and compilers are so fast. I don't know who created vector array or what the rationale behind it is. I've never used it.
Okay, thanks. Yeah, we didn't use it, but we saw it.
I think it is safe to just forget that it exists. You just imagine that we have the native arrays that you guys were playing with in the last class, and then from next week onwards, if and when we start, we will, right? When we feel the need to use vectors, arrays in our programs that we write in class, we'll just use vectors, right? And you'll see it's exactly the same, but vector will take care of a few things, right? So you can think back and forth, and you'll see. Yeah, vectors and arrays are fine. Native arrays, not array arrays. I'm surprised. Thank you, Alex. I think I'll try and find out a bit more. Anything else? Because the plan, I think, today is you have a choice. If you have a question or want me to talk about something, I can absolutely talk about it. Or we can pick up the code from last class and refactor it if you want. Or we can code a brand new problem, right? A brand new array-based problem. I can think up one, or you guys can continue with more problems, right? Come up with your own. That's fine too. I can, step onto the sidelines and watch, right? I think, I don't know if you ever wanted to call me. I think one time in the video, someone called me, but it was so faint, like a mouse, right? And then you gave up after 2 times. So, but yeah, then I only realized that when I was watching the video, but I didn't hear that. So I think you can just feel free, right, to call out loud, right? Or if it's possible to make a sound in Zoom, I don't know. Is it possible to make a sound in Zoom? Some blaring siren or something like that, that's fine, okay? And I'll just hear that. And I'm here, I'm just here, right? And most of the time I'm here. And probably just, on iPad over there, right? I think there is a meeting this afternoon. I might be thinking about that a bit. That's all. All right. So what do you want to do? Do you want to take a look at last week's code, at Tuesday's code? And I can basically walk through this code with you, and we can do a little bit of refactoring like we did before, and also look at the rationale for the refactoring. Look at slightly different ways of doing things, if you guys are interested, right? And you can use that code as an example to talk about this today. Right? I think if this works, I think this is a very cool pattern we can try more than once, which is to have Tuesday classes where you guys code, right? Like on Tuesday, and then on Thursday classes, we could basically take the code and review it together, refactor it. So I think you get double experience, right? If that works, okay. So you can tell me later. All right. So anyone can pick up that code. I haven't seen it before fully anyway, but you guys can guide me, okay? So because I get most of the authors of the code are here today, I hope, right? I think Alexander.
Yeah, the code is on Reddit.
Oh yeah, I deleted the post, by the way. So because in Reddit, when you post code, it has to be formatted properly.
Oh, okay.
Yeah, there is I think in Reddit, I was going to send you a message, but it's easier to just tell you now. I think there's two ways to put code in a Reddit box. I think one is called inline code, and the other I think is called a code box. Basically, it gives you a box inside, and everything you put in there is properly formatted automatically.
Oh, okay.
Yeah, I think something like that. You can just Google it, right? I'm pretty sure you can. Or you can, easier is just put it on a share site and share the link. That might be better, because then people can go and click on the link and also run the code, like on online GDB or something like that, when they give you that link.
Okay.
Yeah, Replete, online GDB, cpp.sh. There's so many of those, so you can just put it in there.
Okay. Yeah. So do you want me to share the code?
Yeah, sure. No, I mean, share an editor with the code in it. And then, however, before you go, let's give someone else a chance. Someone else who maybe, Zaid. First of all, hey, Zaid, I can't see your face, right? I can only see the, top of your, that door or whatever that is, right? Okay, good. So do you want to take the screen and code? Do you have a computer, or are you using an iPad or a phone?
I'm using my iPad right now. I don't think I can.
You're using your iPad?
Yeah.
Can you code on a computer, laptop? You have a laptop?
Yeah, it's just on separate.
Okay, all right. Looks like you just woke up. All right, so you're excused today, but you got to code, man. You got to pick up the screen sometime. Okay, you got to do it from a laptop. Okay, and volunteer to code in class. Otherwise, this class will just be a blur and you won't remember anything. Okay, who else wants to go? Who else? Does anybody else wants to take the screen? Someone who hasn't gone before. Yushin, you wanted to go, right? Are you still on a phone?
I use a phone. My computer is sent to the Best Buy repair. Yeah.
Okay, you got to get you act together and find a computer or a laptop. Okay, at some point soon.
Okay, I think.
All right. Okay, so you got to be online and code. Otherwise, you won't learn anything in this class.
Yeah.
All right. Okay. Good. Who else? Does anybody else wants to go? Otherwise, Lei is going to take the screen and he's going to share and then open up an editor with the code from last class. And then what we can do is just refactor the code like we did, right? Or we can just talk about the code and say, look at things things that we want to do. Maybe also stick in comments saying, well, here's a new problem for us to work on, and then I can take off, right? You guys can work on it, right? On that new problem involving arrays. I swear I was thinking of a new problem, not the looping thing, right? I was thinking of a new problem just as class started. I was thinking this would be a brand new problem to work on with arrays. This would be really cool. And now I can't. I think I seem to have forgotten it, but hopefully I remember, right? Well, as we're coding, remember. Okay. Yeah, Lei, you can just take the screen and open up an editor, VS Code or whatever it is.
Yeah, so when I pasted it back from Reddit to
so they lost the formatting.
GDB,
Yeah, we'll format it. We can format it.
They got rid of the indents.
Yeah.
So this what we first did is find the every pair in.
Great. I see. Okay. So first you wanted to stuff all the. All right. So Okay, so is it okay that we can start refactoring? So clean up the code right from the top, right? So you have got a lot of blank lines and everything. So let's go right to the top, right to the top.
Yeah.
Yeah, clean up all the comments and then get rid of the blank lines. So we'll just clean it up as we go. So it looks nice too, right? No, not all blank lines, right? So you need to have a blank line after the stdlib. Yeah. And then you want time. Okay. So yeah, get rid of that. Just clean it up. Yeah, stdlib.h is the same as cstdlib, right? So if you, in fact, if you go to the include directory and on the platform and look at cstdlib.h, you'll find that it is a file that includes stdlib.h, right? So it's exactly the same. So yeah. So get rid of the comment. Get rid of the comment. So you. Oh, I see. Oh, in fact, what you can do is take the comment and put it on the same line as the include file.
Okay.
Yeah. That's much better. Okay, and time.h, yeah, that's great. And then using namespace, yeah, okay, it's okay. Get rid of, you don't have multiple blank lines, right? So just one blank line is enough. Yeah, also get rid of the space after the hash and then space define. Some people do that. Yeah, did you copy and paste from Stack Overflow or someplace?
Yeah.
Yeah. Get rid of my size F and all that. You don't need that, right? So yeah, that's just a macro and it's all confusing nonsense, right? Yeah, that's a risk of Stack Overflow.
What is a macro?
A macro is, all right, 2 minutes, okay? 2 minutes. Remind me if it takes more than 2 minutes, I'll cut off. All right. In C, I told you that when a compiler sees your program, before it sees a program, there's something called a C preprocessor that's going to take a program and look at every line that starts with a hash, right? And it's going to do some special something to that before the compiler even looks at your code. So if your hash include, it's going to replace that hash include one line with the thousands of lines contained in the file. So the compiler never sees the hash things. It only sees one big stream of characters, right? So the preprocessor has its own language called hash include, hash define, and so on and so forth, right? One of the things that it understands is a hash define, which people can use as macros, because hash define basically says, every time you say hash define x, y, just blindly replace x with a y. And then they did hacky, crazy things like, it doesn't have to be just x, it can be x with a parameter like a compiler and, x with parameters A and B. And it's crazy, right? So you don't want to have multiple levels of languages in your head. So the best thing to do is just forget about hash defines and preprocessor directives and, funny indentations and hashes. And let's just do hash includes for now. And basically the hash define, even hash define, I say let's not use hash defines because C++ const is much better. Because when we use C++ const, debuggers know, right? The debuggers know it's a const. Because a hash define debugger doesn't even know that it's a symbol, right? So it's a hash define pi to 3.141, but the compiler only sees 3.141. It doesn't see pi. And so, but if you use proper C++, you say const float pi equals 3.141, right? Then the compiler, when in a debugger, you'll actually see the word pi instead of 3.141, right? So all of those are really nice. And the reason these things hang around is just because of history, because in those days, we didn't have the sophistication of modern languages. And so people were forced to hack around, and intelligent people come up with intelligent solutions for these preprocessor directives, like hash defines and languages that built into the preprocessor directives and so on. We don't need those anymore, because we progressed on to far greater things. But there are people that follow tradition for the sake of tradition. And they say, oh, I'm a C programmer. I come from Unix days. I got to use hash defines and use this convoluted language just for the sake of it. And people that follow tradition for the sake of tradition without knowing what it's for and what it's trying to address, they don't know better. And they'll suffer, right? Because they're failing to use all the sophisticated features. Thank you. All right. Let's go on. Let's go on to the above main. Is everything above main cleaned up? Yeah. Okay. Yeah. Get rid of one blank space. No, after main space. Yeah. One. Yeah. All right. So no blank space after main.
Right.
Right. Okay. So now what we'll do is let's do it the C++ way. After srand, let's do as we're going to do srand right at the beginning is very good. So let's just do that. After the srand, get enter.
Oh.
No. I'm sorry. After the srand line. Sorry.
Oh, okay.
All right. Now, what we can do is say our array size is going to be, I don't know, 100,000. 100,000 elements in our, let's say 10,000 elements in our array, right? So you say, no, let's say const, right? Instead of using hash define, we're going to say const. So const int, in fact, say size t. Size t is basically unsigned integer, right? From our data representation days, when you have an integer, it can go from minus 32k to plus 32k, let's say, right? 64k possible values in I don't know, 8 bytes, F4 by 2 bytes, right? But if it's unsigned, you can go from 0 to 64k instead of minus 32 to plus 32. Right? So you say, I want to have bigger range and I'm never going to have negative indices, so I might as well make them unsigned, right? So that's what, size t is basically unsigned int, right? So size t, say array size, because it's a const, we can use a convention saying it's all going to be all caps. So ARR underscore size, right? Equals 10,000. Now, when I say any number greater than, this is a practice that I follow, and you can if you want. Right? When I type a number bigger than 1,000, I usually say 10 times 1,000. Right? If it's a million, I say 1,000 times 1,000. And the reason for that is it's a lot easier when you read your program later to say exactly how much it is, because we're notorious to how we can and how many zeros we can count. After there's 3, we'll make some errors. Yeah. So say that it's a 10 times 1,000, and it's not less efficient, right? Because the compiler will change that into 10,000. Because it's just a string, numeric literal. So the expression, so it'll change it. Yeah, that's great. So that's a lot more readable, I think, right? So now, int foo, inside of the square brackets, you say, inside of the square brackets, you say array underscore size, right? And then just put a semicolon after that. You don't have to initialize it right there. Semicolon, just put a semicolon after that, right? So, and yeah, all right. So what I'm doing here is trying to refactor or code what I think you wanted to do. Right. So along the way, if because I looked at your code and I thought, well, this is what you're trying to do now, right? So that's what but I haven't looked at your code before. So if that's not what it is, you should tell me, and then we can course correct. Okay. So no, not all the way. Just the next 10 lines, right? I think what you're trying to do is just have an array full of random numbers. Yes.
The random numbers we use to calculate the average.
Yeah. But in order to do that, initially, you're just starting with an array, and you want that array to have numbers in it.
Oh, okay.
That's what you're trying to do, right? You had equal to, so this equals 16 to 77, 40, and so on. I thought you just stuck those random numbers in there.
Yeah, that's correct.
Okay, so let's just do it the proper way and get the system to generate random numbers for us. Okay, all right. So now what we told the system, now that's right. So now you can go into the next line, blank line. We've finished our declarations, right? Now what we're going to do is put a comment there saying fill the array, right? Fill the array, right? With randoms. With randoms. Right, now you can do your loop, right? So for size t, I equals 0. I is less than array size, right? Yeah. There you go, right? I plus plus. On the next line, right? You don't even need braces. I think there's only going to be one line, right? So get rid of the braces. We'll just do it in one line because it's going to be so idiomatic, right? So yeah. All right, next line, indent in, and you're going to say foo. Let's call it my ints instead of foo, right? Or just call it ints. Just call it ints instead of foo, right? Because foo is very generic. You want to reserve it for some other, ints, right? Ints of square brackets of I. Ints of I equals, ints. Ints of I square, I equals. And now you want to call rand. Open close. How big do you want your randoms to be? 50,000. Okay. Yeah. Okay. 50,000. So you say 50 times 1,000.
Oh, right.
Right. No. I'm saying rand percent 50,000. Percent 50,000. Rand. Yeah. Percent. No. Rand open close. Rand open close. Open close. Yeah. No. Go open close right there. Open close. Because rand doesn't take any parameters. Open close. Now space percent.
Right.
Okay. And then open your parentheses. Yeah. Okay. Right. So rand, that is the remainder after dividing by 50,000. That's your random number. Okay. So that's going to be assigned to ints or by, right? Okay. Now Yeah, semicolon there, right? And now enter, right? Now get rid of the blank line between fill the array with randoms, because that's what you're doing right there, right? So get rid of the blank line, right? So that chunk of 3 lines is your idiom, right? Anytime you have an array and you want to fill it with random numbers, you can do something like this. Now you can put a comment, right? Next line, yeah. You can put a comment there saying at this point, our array would contain, array contains, yeah, whatever, right? Array size, random integers between 0 to 50,000. No, the value, the thing, yeah. Okay, all right, is that okay with everybody? I also say the array instead of array, right? Because if you say just array, say
Right.
array, it may look like, oh, people might think, oh, is it a variable called array? Yeah, okay, all right, cool. So is that okay with everybody? Great. All right. Now, so here's one of the things we should do. Now we know how we do these things. Let's just change the array size to 100 instead of 10,000. Once you got it all working for 100, you can change it to 1,000,000 or whatever you want. Okay, or you can even play with the array size and see how the performance degrades and everything, right? So change the array size to 100, because things we're going to do now, when you run it, you want it to see the result, and change it to 10. Change it to 10. Right? So you just have 10 elements in your array between 0 to, right? Now you can do some simple things if you want, right? Yeah, on the next line, before the comment that says combinations and all, right? So put some blank lines, because our code is go there, right? All right, now you say, example, do a loop to print out the 10, do a loop and print out array size elements, 1 per line. Is everybody okay, right? So I don't want it to be just me and Alex and Alay and maybe Hiram. Maybe I should reduce the size of the font, okay? Or this window, so I can see more of you guys. Is everybody okay with this? Yeah? Okay.
I'm all right.
Thank you. Thank you. Jared is nodding. Yushin? Yushin?
Yeah.
Do you understand what's going on? On your phone, I don't know how much you can see on this phone, right? Because on a Mac, I can't see the screen on this Mac. Even Zaid, even on an iPad, I think it'll be very hard to look at, the screen. Can you see what the code is on an iPad?
I can see. I can see.
Yeah, I can see it pretty well.
Okay. All right.
So are we printing out each value?
Yeah, you can say, yeah, see out, left shift. You say within quotes, always tag it, right? I saw, in fact, I was walking through an experienced programmer yesterday through some code, and I noticed that he had some couts or prints that weren't tagged, right? And so it's possible, I guess, but it's always useful to tag all your prints, because your program is going to produce so much output. When you just run it, you should be able to look at the output and say what's wrong. Yeah, ints, value at index. You can say value at index x, and don't use x. Okay, use ijk for ints. I think I went over this reason before, right? Yeah, use ijk, or even abc is fine. Rare cases, m and o, that's okay. ijk is standard. Everybody does that. And again, you don't need the braces, right? Because it's just one line. If we get used to these things, yeah. If you see, it's only 2 lines, but it's so useful, right? Because anytime you're working on a program, you have arrays, vectors, and so on, and you want to know the contents, right? Just restrict the size of the array and use these 2 lines and plop them in, copy paste random places, and you get a lot of debugging, right? I think it's Brian Kernighan who didn't invent the C++ language, but he was, very instrumental in C, right? I think he said the best debugger of all, well, it's not his words, not Xcode, not VS Code. The best debugger of all is basically a print statement, right? Well-placed print statement. So if you can determine, if you have a good, because, that means it's your head that's doing most of your work, right? You have to develop a good, just like a scientist, right? The best experiment of all is really a very, very simple experiment, right? You don't need sophisticated NASA telescopes to do this, right? Simple experiments are the best experiments of all that even a child can do and knows something really fundamental about the universe. right? I don't know how we got started there. Yeah, print statements, right? So if you know what the problem is with the program, and then you do that sprint and you find out what the problem is, I tell you, the joy is totally unmatched, right? It is a different order of magnitude than, zeroing in on your bug in Xcode, right? So, you set some watch points and break points, step through and say, right? But on the other hand, you look at the output and put some printfs in there and you say, that's what's going on. And you run it and you do it. And it's like, finding a sudden binary star or something like that, right? It's just, so to an astronomer. Yeah, I think if you run it now, you can actually put an exit 0 right there, right? Next line. You say exit 0. No, and always have a space. Yeah, blank line. Sorry, blank line after that. Sorry, it's easier for you. Blank. Yeah. All right, and then say, two enters, and back one. Yeah. All right. Exit 0. This is just tricks. These are tricks that I use, right? Exit 0, open, close, and then exit within parentheses. Exit is a function. You got to pass it the 0
okay.
Parameter. All right, 0 parameter, and then put a semicolon after that. And then what I do is just tag that as 4 forward slashes or something like that, so I know, right? My real program is, but I'm just testing something above that, and I want the program to end after that. That's basically what you're saying. All right. So if you compile and run it, you should be able to see the output, and you should see the 10 random numbers that you chose, right? And every time you run it, you should get 10 different random numbers. Yes.
Yeah.
Okay. Where's your output? I can't see your output.
Yeah, that's weird. Let me see. Maybe this ad is blocking or something. No.
What's blocking?
There's an ad for Rubios.
Just all right. So just copy the whole code and go to cpp.sh. Just copy this whole code. Just copy this whole code. Just because it's easier.
No, I didn't choose the language. That's probably it.
Okay. All right. That's fine. Well, that's why it wasn't indenting properly, maybe.
I could.
All right.
Oh, right, because we changed foo and we used foo.
Oh, you were using
later.
Hey, well, you know what? Go to your program and comment out everything else, right? So put a block.
Yeah,
Start a block. Have you used block comments at all in your code before? In this
Yes.
code, you have used block comments? No, you're just using inline comments. Great. So open a block comment. Open a block comment. Fall forward. Yeah, and then start. And right at the end, right, just before the closing return 0, just before the return 0, right? And then yeah. Hey, I don't know why is someone used a block comment somewhere.
Yeah. No, I'll just get rid of this.
Or you can leave it there and open another block comment right after that. Right?
Okay.
And open another one right after that. Okay. Yeah.
Okay.
Oh no, you got more.
Wait.
Yeah. I saw. I thought I saw
more.
more white ink after that. No, that's it. Okay, run it. There you go. Okay, so if you run it again, you should have different numbers. Yes.
Yeah.
Because of the, you use the srand and time. Different. 40,000. The first number was around 40K.
Yeah,
there you go. So it's changing, right? So now if you go back to your program, now you know how to generate your array and fill it with random numbers, right? So now you can change it to any size you want, but leave it at 10 for now. All right. So, and we'll do all the things, and then later on, and after that, we can go back and change the size of the array, right? So before the exit, so let's say our first task is, what did you want to do first? And we'll just copy and paste your code and then refactor it. Okay.
So it was finding every pair.
Yeah. Okay. So let's do that first. Okay. Let's go to the thing and find every pair. Right. So enter. Right. Just paste it.
Yeah.
Yeah. That's fine. And then we're going to refactor it. Right. We're going to change things now. All right. So above that, above that, put in a comment. Yeah, and say no, blank line, because next para essentially, right? So you say print every pair of numbers. Yeah, is that what we're trying to do? Yeah. Okay. All right. Great. Now here's one thing. I think I overheard you guys struggling to find the size of an array. If you're just given a pointer, because see, that is a nice thing about using the array class. It's just the array class gives you the size of the array. I don't know, but vector class anyway, right? The vector class tells you, because it tells you you don't have to do any complex stuff. I'll just tell you how big the array is. Bam, like that. So it stores. If it's, you don't get it free. It's basically stored in some memory location. So you're basically sacrificing 2 bytes somewhere, right? 4 bytes or whatever it is, and telling the vector class just store the size there. Every time the size changes, right? Change that number too. So even if you change your, vector size, that number is going to change. So there's all overhead, overheads involved. But in the raw array, no overhead, right? So people, and I've seen people complain and say, C++ is a bad language because it gives you a native array which doesn't have all these nice things. But that is really not a clever thing to say, because it does give you vector. Right? Vector class gives you everything that you can get with other languages and even more. But the raw array is so whittled down that it gives you the sheer power of the CPU and memory. Right? It's saying if you really want, you can go all the way down to this level, to the native array. Most of the time we don't do that. Now, if you go all the way down to native arrays, what you're effectively saying is that I know how to find the size of the allocated memory and how many objects I have at this point, right? I'm not going to rely on some funky method that you are going to store, right, and update and give me this number, okay? So how do you find the size? And this is what you were struggling with. It's actually an advanced problem, right? But I'll show you how to do this, right? So the compiler, at the time you create an array, knows how big the array is, right? Because, if this array that you created, it was array underscore size, and that is a constant, like 10 or 15 or whatever it is. Do you guys want me to talk about this? Right? It'll take about 5 minutes, right? So the compiler knows how many bytes it is. So if at any time in that function where the array was created, right? Where the compiler created the array, if you ask it how big is the array, it should tell you how many bytes it has, because it knows. So there is an operator called sizeof that the compiler can translate into the number of bytes. Okay, that is what throws lots of people off. It gives you the number of individual bytes, octets, right? 8 bits, right? It gives you the number of bytes that the array occupies if you use sizeof, right? So if you have 10 integers and you say sizeof that array, that pointer, right? That array, it's going to give you, I don't know, 10 times 4, is it 4 bytes per integer? So it's going to give you 40. So if you want to know how many elements are in the array, as a programmer, that an array contains homogeneous elements, right? You can't have an array that has, a character followed by a long, followed by an integer. Then if you index into the array, you don't know which one to access. Yes, every element has to be exactly the same size in an array. Yes, because that's the power of the array. If they're not exactly the same size, you can take a random index and zoom right into that location. Yes or no? If you know that every element is exactly 4 bytes, and I want to go to the 5th element, I know I have to skip 20 bytes. Yes? So then I can take the address of the first element, right, which is x, and add 20 to it, and go directly to x plus 20, which is the element I want. Yes or no? Now, if instead of every element being a fixed size, as like crazy as linked list or something like that, right? Different sizes each, then I can't do that. I can't do that magic, right? If I have a billion elements, I have to start at the first element and chain through one, bam, 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 until I get to that one I want, which is a pain. So we're going to take advantage of the fact that the array has homogeneous elements, and we know the size of each of these elements. Yes or no? Because when you say I want an array of integers, you're saying I want an array of 4-byte integers. So you know that each element is going to be 4 bytes. You guys have to be in step with me here, right? Because even though it's a slightly advanced concept, but it's not advanced for you. You've done data representation, and it's actually very useful, right? So what was I saying? You know that in the array, each element is exactly 4 bytes. Yes or no? Because when you ask the compiler, right? Give me int, if I 10 lines above, right? We're not looking at the line right now, but you said to the compiler, give me an array of 10 integers. You just give me an array of 10 integers, each of which is 4 bytes. That's what you're telling the compiler. Yes or no? Hey, Yushin, you're scratching your head. Does that mean you didn't understand this? You're scratching your head again. All right. I want to know, right? I don't want to just proceed before you guys understand this point. Okay, it's very important. This is arrays. This whole week is about arrays, right? I don't care if you guys don't get a chance to code today, right? This is an important concept, right? The array has to be composed of homogeneous elements. Otherwise, we lose the power of the array. Is everybody okay with this? Okay, good. So when you say I want an array of 50 integers, you know that each integer is exactly 4 bytes. Yeah, I see. Maybe it's because you're hesitating because I said 4 bytes and you don't know. Different people are using different compilers, right? So modern compilers, integers are 4 bytes. Okay, longs are 8 bytes. Doubles are 16 bytes. Doubles maybe, yeah, I don't know. Maybe doubles are 8 bytes. Yeah. I don't know, right? Because I'm supposed to be teaching you guys, but I got to look it up, right? But it doesn't matter. Let's assume that every integer is 4 bytes long in modern compilers, modern computers. Okay, 4 bytes. This is 64-bit architecture. 64 is, every integer should be 8 bytes, right? I don't know. I haven't even looked into these things, right? So let's assume it's 4 bytes. Okay, all right. So now what I'm going to do to find the number of elements in the array, not the number of bytes, is to get the number of bytes and divide by the size of each element. Okay, is everybody okay with this? Yes. Okay, that is what people do, and don't go to Stack Overflow. I think well, the problem is that I think Stack Overflow and other places sometimes confusing and not necessarily incorrect, but confusing and incorrect for students, right? Maybe okay for certain professionals in niche areas who know exactly what they want to do, but otherwise, I think Stack Overflow ends up confusing you. Because I think you may pick up something about size off. This is what you're trying to do, and if you understand the principles, you can do it yourself. You don't have to write this crazy ass macro, right? My size and shit like that, right? And macros are painful, right? Macros are really painful because things just get replaced textually without understanding the real meaning. Not by you. I'm saying the preprocessor does not understand syntax or things like that in C++. It just go blind replacements, right? And that might introduce bugs in your code, and you can't see the bug, right? Because the bug was introduced by the C preprocessor, right? So don't use macros unless you're like dead sure what you're doing. And unfortunately, the places like Stack Overflow, and the solution actually works and like gets 200 votes or 500 votes or lots of up votes because it actually works. But all of those votes came from experienced programmers who've been using macros a lot of times. They know what happens, right? But now we used a macro, and then Alexander didn't know what that thing was doing, right? What's a macro? Yeah, and I'm glad you didn't know what a macro was. All right, so but sometimes people write macros in editors like Microsoft Word and things like that. What is it? Where a macro is basically a sequence of operations you keep on repeating. Like if you have in your editor, you're going to edit lots of documents, but you need your all of your titles to be styled in a particular way. You triple click that, change the font to Helvetica, font size, make it bold, underline, right? And five steps, and you can record that into a macro, right? And then you can visit each of your documents, or even do it programmatically in Python or something like that, right? So, but if you do it in Word, you basically every time you visit a document without quitting Word, you can basically run the macro, and it'll just change the title automatically for you. That's why Word documents are so dangerous, right? Word, any of these documents that you share, they're dangerous because these macros. Well, now they've gotten a whole lot better, I think. But these macros could basically just go unruly, right? They could go rogue, right? Some of these macros that you get from Excel spreadsheets or Word documents you download on the web, they're basically, malicious macros. They do crazy ass things. And now, Microsoft prevents you from doing many of these things. But previously, I don't even know if you can do macros with Google Docs, but, it'll be crazy, right? If Google allowed macros, and these macros were allowed to get into your documents and your drive, but your Google Doc for many people is tied to your email account and everything. And it'd be a whole order of magnitude different from if Word had a bug in it. So, all right. So anyway, what were we doing? Right. So at this point, let's all right, we print every pair of numbers. Okay, that's all right. So we were talking about how to get the size, right? So go up. We'll write a comment saying this is how you get the size of an array. So up above, right? Go to line number 19. Go to line number 19. Hit enter a couple of times. One more time. Yeah. Now put a comment there. No. One line up, right? Put a comment there. yeah, put a comment there saying, this is how we find the number of elements, guys. Okay, this is how we find the number of elements. If we didn't know, if we didn't know, if we didn't know. Okay, so on the next line, you can say int num size t num elms equals size t space num underscore elms equals size of. Yeah, size of is one word, right? Open parentheses. Oh yeah, I know. I think it's a compiler directive. You don't need open parentheses. It's just a word like new, right? It's a keyword space size of. Now, what is the name of this array? What do you call this array? Ints, size of ints. Yeah, divided by size of int. Does it make sense? Size of ints gives you the number of bytes. Size of int gives you the number of bytes occupied by one integer. Size of ints gives you the number of bytes occupied by the whole thing, right? Now on the next line you can say cout. On the next line you can say cout, cout, and tag it with array size equals array size within quotes. Yeah, array size within equals. Yeah, you can do that. Yeah, array size equals. Oh no, equals. Just put the equals. Equals. Yeah, equals space, and then put array size in all caps, which is the other one. Yeah. End line, and on the next line, copy the whole line and paste it again. End line there. Yeah. Okay. So semicolon. Copy the whole line and triple click on the line. Triple click on the line. No, don't drag. Right. I was telling someone else. Triple click on the line. Get into the habit of triple click. Yeah. All right. Because triple clicking, less of your mind has to be engaged. Triple click. Yeah. All right. Now come in Command C. Control C. Command C. All right. Paste it there. All right. If you drag, your mind is going to be detached for a second. Okay. All right.
I don't think it worked for me.
No. Well, Control V. Control V.
Control D?
No, V, Control V. There you go.
Okay.
All right. Now it's all you paste it there because you Control V not at the margin, but you Control V there. Okay. All right. Now, yeah, put it. Yeah. And now array size. Now you say computed array size. Computed array size because now we want to print num elements, right? In the computed array size. Computed space array size. Yeah. Okay. Equals. Now you put your num elements there instead of. Right now, if you run it, both numbers should be the same. Yes or no? Right. This is a mini test. It's a mini test. So yeah. You run it and find out. Let me switch this off. Just right. So run. What's it going? Put it within braces. Put it within braces. I don't know. Why is it giving you? Why do you have my size off? Where do you have that?
There's a my size of. I guess I didn't delete, but yeah.
No. In here, this function you're calling my size off. Oh, I see.
Yeah, and then it says
all of this is supposed to be commented out, isn't it?
No, this is the print every pair. So,
oh no, get rid of this for the moment, right? Or comment it out. We're going to come and fix it up, right? This is not ready yet. We just yeah. Thank you. That's fine. Yeah. All right. So run it now.
But there is the other, yeah. So put braces around. I mean,
yeah, put braces around it. Put braces around it. Why is it saying that? I'm size off. That's funny. Yeah, well, so why? Yeah, this is the first time I've seen that. I've used size off without parentheses. Maybe it's something here. I'll find out. All right. Anyway, you know that you can use the. Is everybody okay with how to find the number of elements? Right? And it's important in C++, because many times you use an array and you don't know how many elements there are, and you have to calculate the size. How do you need to get past a pointer? And you can do size off on the pointer. I wonder if you get past that, because we haven't talked about functions yet. Forget about it. Okay. All right. Good. All right. Go back to your code. Now we can start filling in. Now we can say. So if you didn't know the size, this is how you do it. Okay. Now we know the size. It's array underscore size. We'll just continue to use array underscore size. Is that okay with all of you? Okay. Now we're going to print all the pairs. All of the pairs. Right. All of the pairs. And you. So. Two nested loops. This is the idiom, right? Just remember this idiom. You're going to be using this so many times, right? So say for size t I equals 0, I equals, do that loop.
Change this
4.
one or make a new one?
No, make a new one.
Okay.
And then you can compare and contrast, right?
Comment this one out or?
Yeah, comment it out, leave it
Okay.
there. No, put it above, right? Because your code is all together.
What do you mean?
No, after the comment that says print every pair of numbers, we can
Yeah.
start typing our code. Yeah. So you say for do the standard loop for size t I equals 0. Same as what you have before. In fact, you can triple click on 28 and paste it here.
Oh,
No, triple click. You did 4. It's 3 clicks. All right. No, triple click on the line again. No, triple click on the line. Triple click on the line and paste. Say where you are. No, on where you want to paste. Triple click first.
oh, okay.
Because if you now it'll just replace all the contents. If you had junk there before, the junk will go and the new line will no paste. All right, there you go.
It still is.
No
this one
change.
not there.
Oh, I see. We pasted the wrong thing. Yeah, triple click there, paste it there. Triple click there and paste it. Yeah, good.
It didn't work.
No, you didn't pay copy. You didn't. I don't think you had Control C.
Oh, okay. Yeah, there you
There
go.
you go. Right now, get rid of that line. No, triple click and delete. Triple click and delete. Don't
Oh,
drag.
all
Yeah,
right.
dragging. I think we should disable the drag button on the mouse. Right, get into the habit of triple clicking. It's much easier. All right, now get rid of the blank line above that. All right. Now here, all we want to do is next line. Now paste the same for loop again, except we're going to change the I to a J. So you can triple click and paste. Right? Yeah. All right. Now you can change the I to a J. No. Oh, I'm sorry. Yeah, I to J. I to J. All right. J equals, yeah. Okay. Now what I want to say is we don't want to start J at 0, right? We want to start J at I plus 1.
Right.
Yeah, so that we don't get pairs of I comma I. Yeah. Okay. All right. Now you can go on to the next line and you can say C out on the next line.
We have to.
No, everything is fine. Go on to the next line.
Make this.
No, because you have less than, you don't need -1. Yes, if it's less than, it's not going to go to I equals 10. It'll go I equals 9. 9 is less than 10. It'll execute the loop. 10 is not less than 9. 10 is not less than 10. So it's never going to access. So you don't need the -1 there.
But if you have 9, there's no element 10 in the array, right? I think.
Yeah, that's fine because
Okay.
it's because put it back.
Oh,
Because what will happen is that J equals 10. Put it back to array size.
oh,
Right? Imagine what will happen. It'll go into this inner loop with I equals 10. No, I equals what is it? I equals 9.
oh, I see. And 9 plus 1 is 10. Which
Yes.
is not
And
less
J was
than
yeah,
10.
right?
Okay.
So go on to the next line. And now you can say C out my pair equals C out pair equals, yeah, pair. And then yeah, you can say equals
So it'd be
ints of I and a comma. I try and put some, parentheses or something around it. Make it look like a pair, right? Maybe put a, first number tab, second number, a comma, first number, comma, second number, comma space, second number, because a comma, otherwise it will look like one number, comma space. Ints of I and then comma space. Ints of J. All right, that's all. That's all of your pairs, and every pair only once. Yes. Now you can run it, and NDL. If you run it, you'll see all of the pairs. Why is taking so long? Why is G++ is taking so long on that on their server? It's taking this long. Yeah. So do you get all the pairs?
it looks like it.
I think so. 10. So how many pairs do you get with 10? 10 times
Yeah,
9 over 2,
10
right?
Or
45. You should get 45 of those. Right? For the first one, you should get 9. Second one, you should get 8,
oh, yeah.
and so on.
Yeah. Yeah, well, you want to, that looks like 45.
Yeah, I think that's all of it. It has to be, all right? Because we know the logic works.
Yeah.
Yeah. So if it's not all, then you'll know. If you want to find out If you want to find out if it's all, if you're really skeptical, instead of random numbers, just stuff them with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then you can look at this number and you can immediately tell if it got all the pairs or not. Yeah.
Yeah.
So where you have the equals, rand, and all that nonsense, you can just comment that line out and say, if you want, not now, right? You can say this array element equals I. That's it. So 0, 1, 2, 3, 4, 5, 6, 7, 8. All right. So now we can try and do the next thing you have in your program. Refactor the next thing. Is everybody okay so far with the refactoring we've done with this? All right. So those are the 3 lines and just remember those 3 lines because you're going to be doing a lot of that, not just here. As you do more testing of code later on in some of the more advanced algorithms, you're going to have to generate your own test sets, right? You're going to have to generate pairs of points and graphs, for example, right? To see if there's a path from here to there, or things like that, all those things. So you're going to have to do this lots and lots of times. And even if you go to an interview and they say generate all pairs, 3 lines, you actually remember, pull it out of there in your memory bank and do it. Now, at least you have a brute force way. It's a brute force way of solving that problem, right? If I said, find all pairs that sum to a particular value, right? Find all pairs that sum to 25,000 in there, right? In that sequence that you had, right? So now you have a brute force way because you have generated all of the pairs. You can find the sum for each one of them. And if it's equal to 24,242, you can print it out and say this pair, all right? And you can do everyone. So, and in quadratic time, it's meaning that you can do it in brute force, every single pair considered. Yes or no? Right, thanks. But if you guys have any questions, if you want me to change direction at any time or stop talking about a particular point and go on to the next one, right? You got to tell me, right? Because I'm really trying to go as slow as possible, right? But sometimes maybe it doesn't work, right? And I don't have enough filler material for other people to catch up and so on. So unless I get feedback, you guys have to tell me, stop right there, right? Or go faster. Sometimes you want to say go faster, right? And you got to tell me. Is everybody okay so far? All right, do you want to do the next thing also, refactor the next thing, or you want to do something else on your own?
What would something else on my own be? Just anything I
Not just you, Lay, all right? If on your own means all of you guys, like last class. If you want to do that, that's fine, right? Or if you want to take the next part that you guys did last class and refactor it again together, just like we did before. Now with the pair generation, we can do that. Right, calculating the mean or median, min, and so on. If you want, I can calculate the min with you guys, right? And then you can do more. And then maybe I'll take a few minutes off and try and think of that interesting problem that I thought I had when I started class with arrays. Right? If I remember it, I'll come back and say, hey, try and code this class. Yeah. Do you want me to find the minimum of all those numbers?
Well, sure.
Or you can do it. You can do it.
Okay.
Why don't you guys do it? Right. I'll just watch.
All right.
Right. Put a comment after print every pair of numbers. Put a comment. Right. All right. Now you want to say find the minimum of all of those numbers. Right. Why didn't you do it? Did you do it already in class?
No, we did not.
No, fine. Oh, if you want to do something you already did in class, that's fine too. Right. If you want to yank some code that you did before and say, shall we try and refactor this? Let's refactor that.
And later, can we refactor the
Why don't we do it now?
two-dimensional array stuff we did?
Yeah, we can do 2D.
You do that.
Yeah, we can do that anytime. Easiest way to do 2D arrays. Yeah.
Yes.
Hey, Alexandria. I don't think we should do 2D native arrays.
Okay.
Yeah. Yeah. I have some reasons for it, but at a high level, it's because when you get to a place where you want to use a two-dimensional matrix, you'll end up using vectors. Because with 2D arrays, the memory management is harder with native arrays, right? Resizing things is harder because if you have 2D arrays basically means give me a bunch of pointers, right? Each pointer is going to point to another array. So technically in C++, you can have a two-dimensional array in which each row is a different size. That's also possible. In C++, you can have a vector of vectors. Now, if all of those vectors happen to be exactly the same size, you get a rectangle. Right? That's your matrix. But technically speaking, in C++, they don't have to be exactly the same size. Each vector could be a different size. In fact, in quest number 2 of CS2B, you're going to be implementing a vector of vectors in which the vectors are of different sizes. It's actually very fun. It's an interesting quest, exciting quest, right? A few students just completed it last week, I think. Yesterday, right? So, but you'll be doing that, two-dimensional. But native arrays, two-dimensional, meaning that I don't even want to have a pointer to elsewhere. I want to have a rectangular, I want to have a bunch of memory locations where each row is fixed, right? The first, here's what you're saying, right? So with 2D arrays, you can say, I want to give me 100 bytes of memory, bam, like that, 100 bytes. Now I'm going to treat the 100 bytes like the first 10 bytes is the first row, the second 10 bytes is the second row, and so on. So my 2D array could effectively be, this space in memory in which everything is fixed in size. If you wanted to rechange, even resize, even change one of the rows, you got to do a whole lot of munging there, right? All of the rows will shift and it's messy. So maybe I'm wrong. Okay, I've done a lot of stuff. I have tried to shy away from using 2D arrays. I have not tried to shy away from using 2D arrays, but I have never used them, right? So let's put it that way. Meaning that you don't have to actively avoid them, but very rare that you're going to come across a situation where you'll use 2D arrays, right? If you have 2D arrays to use, you'll just use a vector of vectors. That's a whole lot easier. Vector of vectors is simple, right? Once you have vector, here's how you declare a vector of vectors. Go right to the top again, sorry. Go not right to the top, right? Go to the place where you have, we'll just answer Alexandria's question, right? Where we're going to start coding. Further up, where we're going to start coding, further up.
Oh, okay.
Right. So here, above find minimum, right? We're going to do find minimum later. Go. Right. Now you say, what is it? Here's how we do a 2D array, right? Here's a recommended way of getting a 2D array. Hint, use a vector, right? Hint, use a vector, don't use a native array, right? And change the TWO to 2D, right? Eventually.
Change to what?
To capital D,
Oh, okay.
2D array, and then hint, use a vector, put it in brackets, right? Put it in brackets. No, parentheses. I'm sorry, I didn't mean brackets, right? Now, if you were to declare a real native 2D array, this is how you do it. I'm going to erase it right now, but it's going to be the video so you can see it. On the next line, you say int space my 2D array, my underscore 2D array, whatever, my 2D array, right? Array, square bracket. No, not equals. Square bracket, array underscore size, or whatever, 10, 10, whatever. Array underscore size. And then the other dimension could be something else. Array underscore, like that. All right. So that's your 2D array. That's how you do 2D arrays. What that basically says, you have an array of other arrays. And in fact, the truth is that I have to look it up, right? If I want to use 2D arrays in C++, in native 2D arrays, at this point today, if I want to use them today, I'll probably spend about an hour looking it up on the net, right? To see how 2D array. This is how you do it. This is how you declare, I think, a 2D array. Because I think in Python or other languages, maybe the syntax is slightly different. You'd have both the numbers will go inside the square brackets, right? You say 10, 15 within square brackets. Maybe in some other languages, that's a 2D array, right? I think in C++, the numbers will go into their own square brackets. And the meaning there is that what you get is an array of arrays. That's a 2D array. Does that make sense? I think that's what it is, right? You can Google it. So this is how you do it using vectors, right? So on the next line, you can erase all of this because we're going to do it using vectors, right? So you can say, so go right to the beginning of the line. You go to where you say int, right? When you do vectors in 2 weeks time, you're going to be using vectors. Okay. This is how you would use 2D vectors, right? Not now. 2D vectors is how you do it. You're going to, on the next, well, erase that line, erase that line. You say Control K, hit Control K, hit Control K. Oh, we didn't do Control K. Oh, just erase that line, erase that line. Go to the beginning, yeah.
I'll just, okay, so get rid of it.
Yeah, get rid of it. Now you want to use vector, right? Now, in order to use vector, we got to go to right to the top. Don't do it now. At the top, you got to say, I'm going to be using vector. Hash include vector has to be within angle brackets. We're not doing it. No, don't.
Uh-oh.
All right, do it if you want, right? We'll use vectors. Right? Hash include vector. All right, if you do this, then you can use this more sophisticated arrays. Now let's do our 2D array. Go to the place where you do 3D array. All right, so you want to say a vector, and a vector is a template class. All right, so and that's the reason I was a little reluctant to bring it up today, but since you brought it up, right now you want to say angle bracket right there after the vector, immediately after the vector, right? Yeah, say now this is a vector of vectors. Yes, okay, and so it's a vector of a vector of integers. So you have a vector of integers which is one dimensional, one row. One row is a vector. Yes, each row is a vector of integers. Yes or no?
Yes.
One row has 10 columns. So one row is a vector of integers. Now what happens if I have a vector of those vectors? Then I have 10 rows, 50 rows. Yes. So that is my 2D array. That is the easiest way to use 2D arrays, because each of those vectors you have a handle you can resize independently. And how the memory of each of those is managed is also very nicely compartmentalized in the vector class. It'll do it nicely. So we want a vector of vectors. So say vector angle bracket, another vector, because you want a vector of vectors. Say one more vector. Now you say angle bracket. Now you say int. All right, close. And one more close, space. No, you need to, no, not that. You can do, I think you can do both together. In the past, right? Even 5 years ago, you couldn't have both of them together. Right? What you had to do what Lei just did, right? You have to have an angle bracket and a space and an angle bracket. And the reason for that was because, even 5 years ago, many people, maybe 10 years ago, right? We didn't know. We didn't know that, or compilers didn't know that two angle brackets together, they're not the C in grade, the operator, the right shift operator. Right, the compiler used to get confused whether it's a right shift operator and left shift operator or vector templating. So now it's okay. I think the modern compilers understand, right? So yeah, space, and you can say my 2D array, right? And you can put a semicolon there, right? And then how you would initialize this, I can show you how to do this. It's very simple, right? Get to the next line. Get to the next line, right? So here you would basically say. My 2D array dot resize. You can actually set the size at the initialization too. I didn't do that, right? So, and you can Google this, right? You can Google this, array size, right? Semicolon. On the next line, you say for your usual for loop. You can copy and paste line 33.
Okay.
Triple click on 33, and yeah, I have it in your buffer. Okay, so you can say on the next line you say my 2D array of I square bracket I dot resize, because now we resize the whole array. So we got 10 rows of empty vectors. Yes. Now we're iterating through each of the vectors and resizing each one of those to also 10 or 15 or whatever you want, right? So here you can say resize 10 or 15 or 100, whatever you want, right? Semicolon. Exactly the same. Now that's it, right? Now you have a vector of vectors. It's a 2D array. At this point, you can say my 2D array of 3, 4, and it'll get that element. So actually 2D array in C++, and it's very thin, right? And we get the nice idea of using a vector class, and the vector class will handle the 2D arrayness behind the scenes for us, right? Because the memory management, and it's very thin because the vector class is very thin, right? It just gives syntactic sugar. We say we want to get that element. It's just translated almost instantaneously, right? Optimized into direct memory access. Bam, like that. Not like in Java and JavaScript and Python. You have to do bounds checking and all these crazy things, right? It's very thin and fast. That's why everything is so fast, right? So, but you have instant replication in Fortnite. Bam, like that. And everything, because they only transmit, if 2 bytes of information is required to go from here to there, they'll only send 2 bytes, right? Minimal header information. Because the header is overhead, right? Every time you send header, you need something like 5G, right? To get a lot of information over. So how do they make that all work, even with LTE? Right, so minimize the header and only send the absolute minimum required bits. And it's possible to do that. We can engineer our own custom way of doing that. But some of the companies have said, for us, this is, in order to transmit the coordinates and the color of the, the visor and things like that, we've managed to distill it down so that we've managed to distill it down into a packet of only 15 bytes, right? And that's the only thing that needs to go over there for them to reconstruct your player position exactly, right? And they've spent a lot of time distilling it down to just those 15 bytes. But I have met engineers who say, we want to do replication on our own. We're not going to use that replication. We're going to use replication with logging, right? Replication with logging is crazy, right? Because replication, you want to be as fast as possible. Replication means two players playing games, right? Simultaneously. How fast someone's actions are replicated on the other person's computer. Half the world across, in China and India, right? Somewhere. And it's happening. You see live streams on Twitch, on Facebook, right? And people are doing this, and it's happening instantaneously. And those kinds of things, I've seen professional engineers too, right? They say I write very robust code because everything I log, and their logs are done with UUIDs that are like 128 bytes long. And it's good. It's good to have logging and things like that for some things. When logging is cheap, right? When you're running a cloud service and then you can just offload everything to a logging bank, a server bank, that's all fine. But for simple tasks where replication is actually a significant overhead, we need to be conversant and know when replication is worth it and when logging is worth it and when it's not, right? So some things like that where you just want to replicate, bam, like that. So logging should be avoided, and a lot of people don't do that. And as a result, they suffer lags, right? So, this guy might just, parachute off, and that guy is still on the plane, and same guy, right? And things like that. So those kinds of things don't happen. I see. That's why things that get really successful and make it out there in a big way, right? Everybody is so crazy about these games and things like that because it's made up of people like you who basically are interested in the algorithm. But they don't stop at the surface saying, okay, well, I know how to put things together at a high level language, right? But I want to know how it's done at a low level because a high level language has a lot of overhead, right? Python, JavaScript, arrays are bound checked, and a whole lot of things happen, and interpretation too, right? So these people eventually get all the way down to the machine level, and they say, okay, this is the way to make things happen instantaneously, right? Or almost instantaneously, or we want to be instantaneous. This is the closest we can get to instantaneous, right? And they're able to identify these things, and they develop these custom solutions when everybody is trying to do general solutions, right? The general solutions most of the time, and that's the other thing that programming lets us practice, right? Train our minds to find the fine balance. It's a very fine balance as programmers to know how much to generalize your function. Right? Many times we write a function or a method and we say, well, you know what, this is a really cool function. I want to make it general. I want to make it handle a lot more than it can. Right? And you say, with this parameter, it'll do that. With that extra parameter, it'll do that. So it'll get more and more general. It'll do more and more things. But 90% of those you're not even going to use, or most people won't use, right? This is just extra baggage, and it gets fatter and fatter like operating systems, right? So that's a fine line. And it only with practice and lots of code, writing lots and lots of code, you learn to say, well, I generalized there, but it was totally useless. But I never use a generalization, right? But you have to feel that after 2 or 3 years. And then you'll say, okay, this function does not need generalization. It needs to fill a very specific niche, right? And that's all it's ever going to do in its life. So I'm not going to generalize that, right? No logging is needed here, and so on. So how do you recognize these things? That is what distinguishes an expert software engineer from run-of-the-mill software engineer, to know when what is needed, right? Before we even start programming, most people don't even know how to put things together, right? But once you know how to put things together, you start developing an intuition for, well, I can put it together in a million different ways, right? What's the best way to do it? Where can I cut corners safely? Because the only way to get there is by cutting the wrong corners. Right? People cut the right corners and get lost. Right. So is everybody okay on how to get get a 2D array in C++? Vector is the easiest way to do. Don't do it the native way like I showed you before, because I didn't know. Right? You can look it up. Or if you want me to, I can look it up and show you how to do it. But I would do it this way using vectors. Long answer for what's Alexandria wanted to do. But is that okay? Was that useful?
Yeah.
Great, thank you. I'm glad I didn't waste like 5 minutes talking about such a simple thing. All right, so if I find the minimum, do you want me to do find the minimum? Right, and then you can do more after that. 3 lines. You got to find the minimum in 3 lines. Can you find the minimum in 3 lines?
Okay.
Hiram wants you to do it.
Yeah.
Okay, so Hiram is going to talk you through the code to find. I'll watch. Okay, and then I can step away when you guys want me to step away. Right. So Hiram is going to call out the code. Don't type. Okay, Lay, you got to be careful not to type ahead, because I've seen this before. First time I handed over to students, guided by other students, the person who's typing sometimes just hears the other guy saying things that they haven't even said yet. Right. You're just typing ahead. Can you watch out for that?
Okay, I won't type ahead.
Okay, all right. Okay, good. Hiram, go ahead. So walk him through finding the minimum. Only 3 lines of code allowed.
Yeah, okay, so first what you want to do is, I would say, make a minimum variable. So since we have integers in the array, we're going to say integer min equals 0 or something. And then we're going to go for loop through the array. So all of the standard stuff.
Yeah.
So yeah, that's it. And then in the for loop, we're going, whenever we see, so an if statement, so if the value of the array at there, so what array are we using? We're
I
using
think ints, yeah.
ints, okay. So if ints I is less than min, then in the same line, just say min equals ints I after that if.
Great. Is everybody okay with that? Thank you,
Semicolon,
Hiram.
semicolon. There we go. Okay.
Thank you. Is everybody okay with that?
Yeah.
Awesome.
So when do you need brackets for a for loop or if statement, and when do you not need?
If
If
it's
you
a
have
single
more
line,
than one.
Oh,
I'm
okay.
sorry, someone else was answering.
yeah, it's all, you don't need the brackets if it's a single line that's
Okay.
in the.
Actually, you can have it on multiple lines if it's a single statement. I think that's what Hiram means, right? The if is one statement, even if it's on multiple lines. If it's one statement, if is one statement. Yes.
Yeah.
So if you only have one statement, you don't need braces.
Okay.
Braces basically give the compiler the illusion that everything inside of it is one statement.
Mhm. All right, and so I guess we'll run it.
Yeah, I think.
I think since we say min is 0, min will always be 0.
What? No.
We start with min equals 0.
Oh,
Yeah, it
yeah,
starts
and
at
all
min
our
equals-
numbers are bigger than 0.
Oh, that's right. Oh, then we can just leave min undefined. Or
Oh, no,
can
no,
we?
you can't leave it
Shoot.
undefined. You got to set
we
it to
can.
max, right? You got to set it to the maximum possible number you know. Yeah.
Okay.
In this case, it's very simple, right? We know it's the maximum is 50,000, but I'll tell you how to make a, there's a maximum number. Oh, there is you're going to do it there?
Oh no,
Oh, it's
the
just vector. It's
compiler
not
will
vector
say
dot h.
something
No, no, no,
about
it is vector. It's vector dot. It's not vector dot h. It's just vector.
Oh, okay.
So go back to the thing. Yeah.
Right here.
What was I talking about? I forgot.
You said you have to set min to the max. of
Yeah.
these.
I think it's called int underscore max. Type int underscore. Is it max int or int max? Well, you can Google and find out. You can Google int max, int underscore max. No, it's uppercase, all uppercase, by the way.
Okay.
Maybe leave an autocomplete. Just say uppercase int underscore. Underscore. No, it doesn't. But do max, int max, max. Int max. Is it max? No, it's not. No, I think it's int max. Int max, and then Google it. Someone find out what it is. Or maybe you have to include a file, ulimits.h or something like that.
Do
But
what?
we'll see.
Oh, one of these.
Yeah, maybe include hash include ulimits.h. I don't know. I'm very unlikely this might be the solution. Ulimits.h, ulimits, Unix limits. I think so, right? So now go and autocomplete int underscore. Ah, damn, just Google it. It'll tell you what to use. Just type int max. Int max. Yeah, okay. C++, int max. Yeah, I think that's fine. Yeah. Max value of int max and int min. Right, the third one. Click that, it'll tell you what the include file is. We just want to know what the include file is, so it auto completes. No, there.
This one.
Ah, okay. Just triple click that and put it in. Did you hit Control C?
Yeah, I did.
Get rid of ulimits. You don't need ulimits. Yeah, that's the other thing that we need to make a habit is as soon as you find out that you don't need an include file, get rid of it, because otherwise it's litter. Like in Java, how many times many people have seen Java programs with a whole lot of imports, right? Most of them not even used. These packages are historical, right? So it tends to accumulate because it doesn't cause any problems. So we should be more on the lookout for things that don't cause problems than things that cause problems. Because things that cause problems, we always know. It's self-announcing. But things that don't cause problems, they don't announce themselves. That should work. That should work. Right? Now, int max should autocomplete. Int max should autocomplete.
Oh,
Some
No, I think,
whistling is it just
also we
me?
need to change the name of the variable to max instead of min and. Oh, I see. Min.
Oh, yeah.
We're trying to find, no, wait a sec. We're trying to find the min. Yeah, min equals int max. Min equals int max. Yes, that's fine. That's fine. That's fine.
When I tried to run this on my version, it said that it needed to include C limits. I don't know if it'll happen here.
Oh, C limits. Yes, C limits. Not yeah. C limits. Hash include C limits. Yeah. C limits.
.h or no?
No. If it starts with a C, it's a C++ file. You don't need .h. Now go back to the place where you were using the. Yeah, I want to just make sure the syntax is correct. Okay, it was complaining min equals int max. Does it autocomplete int max now? Int max now? Just see if it autocompletes int max. It still doesn't. But it's not. It's Xcode would have done that. I think it's because of online GDB. It's not reading the include file. All right, good. What was the complaint? It had a complaint.
Oh, I think it might have had to do with int max though. And now that we fixed, still there.
What does it say? Now, invalid operands of type int and binary operator less than. Ints of I is an integer. Min is an integer too, isn't it?
Yeah, integer.
Int. Min is an integer. Ints of I.
You copied the size t I, so I is a size t.
But ints of I should be an integer.
Yeah. No, ints of I, size t, that's fine. Int. Everything is an int.
Shoot.
Did you, is this a copy and paste from, this is really puzzling, isn't it? Why can it not, can you retype the whole thing? Maybe it's a funny character there.
Okay.
Retype the whole thing. If ints of I less than min equals ints of I. Why did it? Yeah, that looks perfectly legit to me, right? All right, let's figure this out. What time is it, by the way?
Maybe we see out.
We got 10 minutes.
Or
Ints of I is less than min. All right. So invalid operands of type int. Type int, and then it has that funny thing. It cannot tell what the type of int is for some reason. It hasn't got a type for int min. Turn int into string. Int min to string mint for a sec. String mint for a sec. String min and turn int max. Put it in quotes. Now it should tell us an error. You should give us an error saying invalid comparison of a less than operator between an integer and a string, right? It should tell us that the right-hand side is a string.
oh.
So why isn't not saying that it can't see that you're comparing an integer and a string? It cannot see. Go back to the code. This is very puzzling and juicy, right? So we can figure this out. We got 10 whole minutes. All right. Where is it? Int of I is less than min. Now break up the int into two. Break up the if into two lines, right? 2 lines. But yeah. Enter. Indented. All right. Int of I is less than min, and it doesn't like that line. Do it again. Compile it. Just make sure that. All right, so that's exactly where it has an error, overloaded function with no contextual type information. So ints of I is an integer and it's not able to assign it to an int, right? So ints of I, maybe it is the name of the variable. Maybe we shouldn't call it ints. But what is the type of ints? Is it an array of integers? Let's go back. It should be a vector.
Yeah. What?
Oh, I thought we were using vectors now, and we went back to using native arrays. That was the issue.
Vector for.
I thought we started using vectors all of a sudden.
Yeah. Wait, no.
My 2D array. I'm so sorry. We should be working with my 2D array, not ints. Ints is a native array that we started. Then we started using vectors and we called it my 2D array. So let's go back to right at the top and change the native array into a vector. Yeah, make that a vector. Vector. Vector of ints. Yeah. And then ints. Now here's how you declare a vector with the given size at the time of declaration itself, right? So array size, make that curly parentheses instead of square brackets. So that is exactly the same as declaring a native array, except you got all the vector niceties on top of that. Is everybody okay with that? Maybe that was a useful digression, I think, right? Now you know how to declare an array just like a vector. Is everybody okay? It's exactly the same. Now, if you run it, I think it should work. I think it should work. If not, we'll find out very quickly. All right. Yeah. Now, I think it's easier to find out. All right. Vector of int.
Oh, it's I typed ints instead of int.
All right. Okay. All right. We were getting somewhere. No. Good. Oh, I see. It still has the same invalid operands. All right. And blank. All right. So for some reason it doesn't. I can't tell. Right. Less than 5. Make that less than 5 instead of less than min. Give it the number 5 instead of
So is min a keyword or like a method maybe?
Yes.
Like
yes. Thank you. Who said that?
That's me.
Thank you, Alexandra. All right. So I think that's probably what it is. Jeez, I totally forgot. Yeah. Min. Min is the name of a function, a math function, a library, a function in the math library. So it says I can compare an integer to a library function name. So call it mymin. Mymin. All right.
That would explain why I wasn't getting that error myself.
Yeah.
Yeah, I Googled it.
Yeah, good. Thank you. Yeah, that's fine. I think mymin was not declared. Oh, but change int, and make that int mymin, and then change that into int max. Int mymin, and change it to proper int max. All right, that should fix it. Mymin was not declared in the scope. What's going on? Maybe it's a spelling error. Go back to your code. Oh no, it's not int. Oh no, int mymin. No. Oh mymin, int mymin equals int max, and then if
is it the for loop on line 43?
Yeah, could it be this?
Like it's saying mymin is being declared in the for loop.
Hey, what's that error? What's that array doing up there? You got an incomplete for loop up there?
Right.
Where did it? How did that get into our code? I don't remember typing it in.
Yeah, I think.
Get rid of. Make the comment. Yeah, but put the 2 lines above that in comments too. Now remember, there's a digression about the 2D arrays, right? Put all the 2D array things in comments.
Okay.
We don't need any of that. But it's just yeah, that was causing a whole lot of issues.
There we go.
All right. Okay. Yeah. I completely forgot about the digression. We were talking about 2D arrays, and then we left the junk in the code and then started working on other stuff. Right. Go to the top. I think that's on the top is where you have the.
Oh no, we never see out it.
Oh, you didn't do any cout. All right, now
Right.
you want to do a cout and say min equals my min equals, yeah, the minimum or yeah, whatever.
And it says less than 5.
Oh yeah,
Oh,
fix
okay.
that too. My min. Thank you, Alexander. All right, that should work, right? That should work. Okay, min is 3450. Let's go to the top where you're printing out the whole array. There you go.
Yeah.
Yeah, okay. Now that you know that it's working for 10, you can make the array size bigger. You can make you can go to your code and make your array 100,000, right? 100 times 1,000 instead of a 1,000. What is it? 10 times 1,000? Or do you have 10? You can say 100 times 1,000. And now you can get rid of the place where you print out the array contents, right? Now you know that because the array has so many items, you can't print out all of the, because it'll just overflow your screen. You've got to wait forever. So comment out all the code where you print out the comments. Yeah, comment out the code where you say, and then also the pairs.
Oh, yeah.
Right. Okay. So now is the array big? Is you have 100,000 elements? Wow. Okay.
Yeah.
All right. And the smallest element was 6.
One.
Oh, then 1. You actually hit a 1. Maybe it's turning out to be a game, right? Is it possible to get a 1 or not? What's the odds of getting a 1?
Wait, hold on a
Odds
second.
of getting a 1 or 1 in 100,000. What is our modulo?
Computed array size is 6. Maybe that's.
Oh, there's a bug. No, because
It's
we're not
because you
using native
changed
array
it.
anymore.
Yeah, that's it.
Yeah, you can comment this out. Is there a bug? Is there something that needs explanation? I'm not following here.
Computed array size equals 6. So
Oh, it
somehow
does say that.
num
Num elements is 6. Is that
is 6? Yeah.
All right. Size of ints. Where's size of ints? Ints. Where's ints?
This
Sorry,
is
size.
this.
Oh, 100,000.
It used to be a native array though, so now it's a vector.
Oh, yeah.
Oh yeah. Now it's vector. I see. Size of vector is not the size of the native array. We messed up a lot of things by changing things for experimentation. It's not a native array. Thank you. Hiram pointed it out, right?
That's correct.
It's not a native array. That's why this got messed up. So you need to comment that out too, because
Okay.
now it's not correct, right? And also change the comment later on. When you say in an array, you should say in a native array, right? Because now, right? So in fact, we got 0.
Oh, wow.
What are the odds of getting a 0? Oh, we got 100,000 elements, right? So 1 in, the remainder, 1 in 50,000. Run again. Yeah, so inevitably we're generating a 0, which means we're generating a multiple of 50,000. Yes, this is a multiple of 50,000.
Yeah.
So of the how many numbers are we generating? 100,000 numbers. Of the 100,000 numbers, at least one number is a multiple of 50,000. And so you can play with the odds and figure out a way in which you can get numbers such that the minimum is not always 0.
Mhm.
So I mean, those are things, scope for experimentation and playing around. So you can increase the size of the array. Now you can see, right? Now you can see pair generation. You don't have to print all the pairs, but just enumerate all the pairs and say, that many pairs. I can find that many pairs, right? And now you can see the pinch, right? When you grow the array size from 10 to 100 to 100,000 to 200,000, a million. Now you can say this is the number of pairs, and you do it quadratically, brute force. You can see even in online GDB how slow it goes, right? So those are good experiments to do. So
Okay.
obviously, when you don't print out all the pairs. Just count the pairs, because you can't. If you print out all the pairs, you got to sit down in front of the console for all day. So if you count all the pairs, you guys want to do it on your own? Yeah.
I think, yeah.
Okay. All right. I can step off screen. Right. I'll step off screen, and you can call me if you're stuck. Okay. And the last person to go, just call out to me, right? Because then I can stop the recording. All right. Thank you guys. Was this class useful? Was this a useful class today? Yeah.
Yeah.
All right. Would you like more of classes like this? Right. So we do a Tuesday class where you code, and then on Thursday class we basically dissect the code, look into more, refactoring of it, introduce more concept and ideas and related things. Yeah. Is that okay?
Mhm.
Okay. All right. So I think that's working for me. because then I can see myself doing new stuff every quarter. That if it works, we'll leave it like that, right? And then, in fact, maybe I'll make a point in the program review. We're going to do program review for, because we only get a chance to do program review in our department once every 5 years. I think that's a state mandate, right? But I think computer science should really do program review every 2 years at least, right? Because things are changing so fast. But we'll have a chance. I'll bring this up in program review and say, if classes are structured like this, where students have more input, and then the lecturers, like an art class, right? Where students are actually doing stuff and the lecturer walks around and says, you can do it this way, it'll be better, right? And does it that way. And because programming is an art, at the end of if you think about it, right? And I think that's actually working out better. I'll talk to Beta and Ram and see if something can be done. All right, so I'm going to step off screen. I'm going to mute myself. And if you want me, just call out, okay? Yeah, I'll be there. Thanks. Fantastic job, right? I'm enjoying every moment of the lectures and watching these videos, right? Talk to you later. Bye.
Our class is almost over. All right.
Yep.
So, I mean, then everybody has to go.
Yeah.
What exactly are we doing?
We're supposed to, I mean, if we want to try something else now, I don't think you realized class was open.
By the way, you can find the max, min, and mean, just like
Okay.
min, max, min, and mean. Lots of things, right? And I'll try and think of something, right? Maybe I'll post it on Reddit if class is over by then.
Okay. Well, I kind of have to go. Does anyone else? So I'll stop sharing.
I mean, I can do it if no one else wants to. But
I probably have to go
See you
too.
guys.
Sorry,
okay,
guys.
in that case, maybe we should just not. I don't know.
Bye.
Well, okay then.
Yeah. Do you want to do anything?
Right now I'm just, Googling stuff and looking things up myself as he said. So,
Yep.
But it was really like right now I'm reading about like vectors some more. But yeah, I don't know. I think I might just post some cool stuff I found on Reddit. But I think the one thing was like I was having a little bit of trouble like reading through because there's like so much commented out. I was like, wait, I forgot the code that was on top. So I'll probably have to go back and review the parts that we were actually using. So okay then.
Sounds like
Cool.
we should
Then I'll
just go
just
most likely.
see you guys Tuesday, possibly.
Yeah.
All
See you
right.
Tuesday
Thank
then.
you.
Bye.